Okay, so let's keep going. Now we're going to do example 2 for the independent t-test. All right, so let me go look here. All right, we talked about Cohen's d. We did example 1. And remember example 1, and I'm going to quickly show it to you just so it could jog your memory. I had the statistics for each sample. I didn't have the actual data. But for example 2, I'm going to have the actual data. So let's go here. So a teacher believes that her 8 a.m. class doesn't perform as well as her 11 a.m. class on the final exam. At the 5% level of significance, is there a difference between her 8 a.m. and 11 a.m. classes? So here on the left is her 8 a.m. final exam scores, and here on the right is her 11 a.m. final exam scores. Two different samples. They're independent of each other. So now we can do an independent two-mean t-test. All right, I'm going to answer the same questions that we did before. So let's quickly go through part of them. So is this a test for two means or two proportions? It's two means since we're talking about averages, and I don't have anything about percentages or proportions. Are the population standard deviations known or unknown? They're unknown because I didn't mention them. They weren't anywhere in there. All I really had was raw data for two different samples. And which distribution am I going to use to perform the test? I'm going to use the student t since there's no population standard deviation. So what are the null and the alternative hypotheses? All right. So if you go back, it said, is there a difference? It didn't say, did 8 a.m. do less than? Did it do greater than? It didn't. It just wanted to know it was different. So again, I'm going to look at 8 a.m. I'm going to do that as sample 1. 11 a.m. is going to be sample 2. So my null is that the average final exam grade for the 8 a.m. class equals the average final exam grade for the 11 a.m. class. The alternative is the average final exam grade for the 8 a.m. class does not equal the average final exam grade for the 11 a.m. class. Is this a right-tailed, left-tailed, or two-tailed test? It's a two-tailed since the alternative does not have the equal symbol in it. And what is the p-value? All right, I'm going to have to use Minitab. All right, so remember I was given all my data. Remember, here's my data. So I've got to put the data into Minitab, and I'm going to do it in two different columns. I've got one for 8 a.m. and one for 11 a.m. And I'm going to show you here, okay? Oops, let me bring this up a little bit. So here you see my 8 a.m. and my 11 a.m. All right, so what am I going to do? Stat, basic statistics, to sample t. Now I'm not going to use summarized data. I'm going to put each sample in its own column, right? Sample 1 is 8 a.m. Sample 2 is 11 a.m. I'm going to do options. All right, this one I did, it was a 95%. Hypothesize zeros is always going to be the same, and then it's not equal because that's what my alternative is. I'm going to assume equal variance is checked, hit OK, hit OK. So then what am I given? And I'm going to put this down. Okay, again, I'm given, it tells me what it tells me what the mean 1 is. So I'm saying it's the 8 a.m. class, and mean 2 is the 11 a.m. class. And it says difference between the two. Okay, it's basically what we just talked about, but it's telling you, hey, this is how I ran this. Always check yourself. Don't get them flipped. Gave me the descriptive statistics. All right, for the 8 a.m. class, I had 9 students. The average final exam grade was 56.6 with a standard deviation of 22.1. For the 11 a.m. class, I had 9 students take it. 76.9 was the average final exam score with 13.8 as the standard deviation. Estimation of the differences. The difference is negative 20.33. The pooled standard deviation is 18.45. I've got my null and my alternative hypothesis, which is what I want it to be. T-value is negative 2.34. Degrees of freedom is 16. And the p-value is 0.033. Okay, so let's go back to my slide. So I've got everything I need. So I'm going to go here now. So what was my p-value? All right, so if I go back, yep, all right, so p-value was 0.033. So since 0.033 is less than or equal to 0.05, and that is a true statement because 0.033 is less than 0.050. And again, I put that 0 so I can compare 33 to 50, and I know 33 is less than 50. So I reject my null hypothesis. So let's go back up again. So if I'm rejecting my null hypothesis, let me go here. Oops, excuse me. If I'm rejecting this one right here, if I'm saying that's not true, then I'm saying this one is true and there is a difference, okay? So I'm going to put this. So I'm going to take this with me just so you can see what I'm doing. Okay, that might help. So now I'm saying my alternative is true. So the average final exam score for the 8 a.m. class is not the same as the average final exam score for the 11 a.m. class. So at the 5% level of significance from the sample data, there is sufficient evidence to conclude that the final exam scores for the 8 a.m. class is different from the final exam scores of the 11 a.m. class. So I didn't ask if it was less. I didn't ask if it was more. I just asked if it was different, and I've answered that question. Remember, you can only answer what the question is being asked. Don't make any other assumptions. Now, I can go look at it and see here, well, the average final exam score for the 8 a.m. class and the 11 a.m. class are very different. It's almost 20, it's more than 20 points different. So that's what that tells me is, yes, something's going on with my 8 a.m. class versus my 11 a.m. class. So that's what that tells me right there. Okay. And again, level of significance, I put there sufficient evidence to conclude that there is something different going on about the final exam scores for both classes. All right, now I can do Cohen's d. So remember, I already had my estimate of the difference. So I had that negative 20.33 and then that 18.45 for the pool standard deviations. So if I go ahead, plug it in, I get negative 1.102. All right, so this effect is large in negative y. All right, remember the negative sign shows me the direction of the relationship. The 8 a.m. class didn't perform as well as the 11 a.m. class. The 1.102 is larger than 0.8, so my effect size is large. So the size of the difference of the means for the two colleges is larger, indicating that there's a significant difference between them. I'm going to put college classes here just to make it easier. Okay, so what does that mean in layman's terms? Okay, something's going on with my 8 a.m. class versus my 11 a.m. class. For some reason, they're not doing as well as my 11 a.m. class. And think about it as a student. A lot of students don't want to take 8 a.m. classes. They maybe aren't up, they aren't ready to be listening to a lecture. They don't test that well first thing in the morning. They might have not slept well. And then they came in and had to take one very early. And think about 11 a.m. People might have more time to prep for the test before the 8 a.m., just those kind of things. That's why there could be a difference. And again, Cohen's d, I did find there was a difference, and then Cohen's d told me there's a large negative difference between the two. And I saw that. My 8 a.m. didn't perform as well as my 11 a.m.